All right. Hopefully I can give you a small brief tutorial on how this works. Trying to do this clearly, but so here's my setup for a Blade 400 helicopter. You can see curve 1 is my throttle normal, curve 2 is my idle up 1, curve 3 is idle up 2. So you can see the curve difference is here. What you want to notice is the center dot. So for throttle curve normal, you can see it starts out at idle and then starts spooling slow. And then when it gets to the middle, the 50% range, that's your head speed at 0 pitch. And as you increase collective from there, you're only trying to keep that RPM, that sound of the head speed. So if you go more collective and you hear the head speed go down, you need to know where the throttle was roughly at that point and then give it a couple of more bumps on that percentage of the throttle curve. But basically you want to start out, this is your RPM, this is your head speed at 0 pitch. So know that sound, know what it sounds like, and then go from there. So you want to keep that head speed sound the same throughout the entire pitch range, except for when you're in throttle curve normal, which has to go down to idle. So you have to start out from somewhere. So you start out from idle, go up to 50% range. There's your head speed RPM, and then you don't want to lose or gain any RPM when you go more pitch. You can see the pitch curve for normal starts out at roughly negative, 3-degree pitch on the blades, and then goes to 0 pitch, and then goes linear up to 100%. So for the normal pitch and throttle, that's what it looks like. Here's your pitch curve for normal mode. Since you're not going to do any 3D stunts or anything like that in normal, because when you drop the throttle down, or the collective down, it's going to kill head speed, RPM, and all that, so it can come down to idle. So that's what the normal throttle curve is for. You won't need pitch to go down to negative 100% because you're not going to be inverted in a normal mode. So there's your pitch curve for idle up 1 and idle up 2. You can see they're linear, negative 100 to positive 100. The only difference right here is the throttle curves. So look at that center dot. That's your head speed RPM. So you see normal, idle up 1, it's going to raise the head speed for 0 pitch, and idle up 2, it's going to raise the head speed even more for 0 pitch. And then those curves are set based on how I fly and how hard I hit the collective, plus or minus. So hopefully that helps a little bit. But yeah, if you limit your normal mode head speed, it's going to soften up the collective a lot. It's going to make it a lot more easier to learn, or actually I use it a lot just for flying around in small areas. You don't want the head speed ripping. You just want it kind of a little bit mushy, to put it simply. So I like the head speed a lot lower. It softens up the collective and the pitch and yaw and everything. Makes it a lot easier to fly. But when I started out, my head speed was way, way, way too high. It was a nitro motor, and as I changed locations from the first time I flew it to the second time, the head speed RPM had changed because, motors increase or decrease in RPM based on rich or lean without a governor. So that was my major problem. That's when I learned about head speeds, and that can be tuned to the user's preference. So check out your normal curve, and then everything below this curve you tune however you want to spool it up. You can start low and go exponential, but up to the center dot, that's going to be your head speed. So lower your head speed, fly it, start applying collective. If the head speed goes up or down, change this next dot. Try to fly it again. More collective, and then so on and so on. So You don't want the head speed to raise or lower in RPM throughout the collective range in normal mode. And that's about it. Let me know if you got questions. Thanks for the video though.